Hello students! Welcome back to part 2 of the electronic lesson. Today we are going to learn about transistors and logic gates. Transistor. A transistor is a double p-n junction with 3 terminals: emitters, base, and collector. The emitter emits charge carriers through the thin base layer to be collected by the collector. There are 2 types: NPN transistor and PNP transistor. In a NPN transistor, the emitter sends negative electrons to the collector. In a PNP transistor, the p-type emitter sends positive holes to the collector. The arrow on the emitter shows the direction of current flow. The output current of a transistor flows between the emitter and the collector. The current in the collector lead is called the collector current, IC. The base current, IB, is used to control the collector current through the transistor. The base current can be used to switch the collector current on or off. Collector circuit is controlled by the base circuit. Current will only flow in the collector circuit when the circuit is switched on. The base current is too small compared to the collector current. The unit of base current is ampere, while the unit of the collector current is milliampere. Emitter current, IE, is equal to the sum of base current and collector current. IE is equal to IB plus IC. Transistors as current amplifiers. It is the major application of a transistor, used to amplify or magnify current changes. A small change in base current produces a large change in collector current. The graph below shows the relationship between the base current and the collector current. From the graph, we can conclude that the collector current is directly proportional to the base current. Since the small change in the base current IB results in a big change in the collector current IC, the transistor therefore functions as a current amplifier. The amplification factor is the ratio of IC over IB. Transistors as an automatic switch. If there is no current flow in the base circuit, then there is no current flow in the collector circuit. If IB is equal to 0, then IC is also equal to 0. Transistor is switched off. If IB flows, then IC flows. Transistor is switched on. Voltage across the base can be controlled by a potential divider. According to the potential divider rule, the voltage across the resistor R1 and R2 can be calculated by the formula. Thus, by varying the resistance of R1 and R2, we can control the voltage across the base V2 and turn the light bulb on and off. Let's move on to logic gates. It is a circuit that has one or more input signals but only produces one output signal. Each signal and output can either be high or low. Types of logic gates: AND gate, OR gate, NOT gate, AND gate, NOR gate. AND gate. For input to be on, input A and B must be on. OR gate. For the output to be on, at least one of the inputs must be on. NOT gate. The output is on when the input is off, and vice versa. AND gate. It is equivalent to an AND gate with its output inverted by a NOT gate. NOR gate. It is equivalent to an OR gate with its output inverted by a NOT gate. Let's look at a transistor working as an amplifier. Aim: to show a transistor acting as a current amplifier. Materials: transistor, resistors of 2.2 kΩ, 3.9 kΩ, 4.7 kΩ, 6.8 kΩ, and 10 kΩ. Connecting wires, and dry cells. Apparatus: milliammeters with range 0.1 milliamps to 100 milliamps. Caution: make sure the terminals of the transistor are connected correctly to avoid damaging the transistor. The electrical circuit is set up as shown in the figure. Switch S1 is closed. The readings of the base current IB on the milliammeter A1 and the collector current IC on the milliammeter A2 are recorded. Step 2 is repeated with switch S1 open and switch S2 closed. The readings of the ammeters are recorded. Both switches S1 and S2 are closed. The readings of the ammeters are recorded. Step 4 is repeated by replacing the 10 kΩ resistor in the base circuit with resistors of 2.2 kΩ, 3.9 kΩ, 4.7 kΩ, 6.8 kΩ, and 8.2 kΩ. All the readings are recorded. The graph of IC and IB is plotted. The results that we can conclude from this experiment is S1 closed, S2 open, IB equals 0.08 milliamps, IC is equal to 0 milliamps. When S1 is open and S2 is closed, IB is equal to 0 milliamps, while IC is equal to 0 milliamps. Both S1 and S2 are closed. Figure shows the graphs of IC against IB. When switch S1 is closed, the milliammeter A1 gives a non-zero reading for IB. Meanwhile, milliammeter A2 gives the reading for IC, which is equal to 0. So it can be inferred that the current only flows in the base circuit. When the switch S1 is opened, the switch S2 is closed. Both milliammeters A1 and A2 give a 0 reading. It can be inferred that there are no current flowing in both of the base and collector circuits. When the base current IB increases, the collector current IC increases. The gradient of the graph represents the current amplification. A transistor amplifies current by increasing the collector current if the base current is increased. A small increase in the base current IB results in a big increase in the collector current IC. Let's look at one of the past year questions. Diagram 4.1 shows the structure of a simple cathode ray oscilloscope, CRO. Based on diagram 4.1, name the component T. Please pause the video and try it yourself. The answer is cathode. Explain what happens to the electrons on the surface of T when T is heated. The answer is cathode, or T emits electrons when it is heated. Name the physics process in A2. The answer is thermiotic emissions. A student uses a CRO to study the output voltage of a bicycle dynamo. The time base is set at 100 millisecond per division, and the Y gain control is set at 0.5 volts per division. This is the hint for solving this question. Let's give it a try. Calculate the frequency of the wave produced by the bicycle dynamo. The solution is time taken to complete one oscillation, t equals 4 times 100 milliseconds. T is equal to 400 milliseconds. Frequency, f equals 1 over t. F is equal to 1 over 400 milliseconds. F is equal to 2.5 Hertz. The final question. On diagram 4.2, draw a new trace to show the voltage output if the frequency of the dynamo is doubled. The solution is shown in the figure below. Congratulations! This concludes our lesson for Chapter 4. I hope to see you all back for Chapter 5. Bye!